in this video. Hello everyone and welcome to our second series, Algebra 2. This is the 14th video of the channel and the first video of the Algebra 2 series. Yup, we are done with the Algebra 1 series. No more of any of that stuff. Now we're moving on to the more advanced stuff, Algebra 2. But, of course, before anything, please make sure to like and subscribe for more awesome content just like this. Without further ado, let's get on to our answers to our previous questions. For our first question, the answer is y is greater than 3. For our second question, the graph is shown right here in red. This is the graph. It kind of looks like this. And the line is in red. That means that's the graph. And the black part is just the number line. And for the third question, our answer is x is less than or equal to -2, which it actually shows right over here, of course, on the red line graph. So it distinguishes it. So you can see, okay, this is the graph, and you don't get confused. Because if I draw something like this, it's a little bit confusing. But if I draw something like this, it's very clear. So I just did that to make sure that you could see it more easily. Without any further ado, let's move on to the first lesson of the Algebra 2 series. Today's lesson is about solving compound inequalities. So compound inequalities are kind of like the inequalities, represented in the last video. Trust me, you should watch it. But you're actually going to have two of them, and they're going to be connected. So let me explain. Sometimes, normally, even a compound inequality, you're going to have two inequalities. Let's say x is greater than 4. And there's going to be one of two words connecting it. And, or, the second word is also or. So it could be and, something else like x is less than 3. Or it could be or. These are the two possible two possible words that could be used. And that's normally going to be the problem that's going to be stated. Like if I have x is greater than 4 and this or this, that. So I think you get the point. And the solution to the inequality, like what we normally wrote in our last video, was, okay, x is greater than 3. This time, we're going to have to write something a little differently. So if x is greater than 3, it's going to be 3, infinity as the solution set. What the solution set means is that these are the numbers that satisfy the inequality. Kind of like the solutions of linear equations, except it's for inequalities, but we call them sets. Because normally it's much more than 1, it's kind of infinite, unless, of course, there's limits. So if we do that, you might be like, oh wait, so this is in the set, this is not in the set, blah, blah, blah. So what does he mean? What I mean is that this means it's not in the set. Like x is greater than 3. So 3 is not in the set because 3 is not greater than 3. 3 is equal to 3. And whenever we have negative infinity or infinity, we're always going to have the bracket on the right side. Some people call it parentheses. I just call it bracket. And for our second one, it's in the set. So what we're trying to say here is, let's say it was greater than or equal to 3. It would be, instead of that, we would have 3 with the parentheses and infinity with the brackets. And if we have and or, that's where an entirely new realm comes in, which I am actually going to explain right now, because, of course, this is still the lesson. The and normally has something called the intersection sign, which kind of looks like a backwards U or upside down U. Normally, let's say I have x is greater than 3 and x is less than 4. And let's write that in the middle. What we're going to have here is okay, if x is greater than 3, 3 is the lower limit and the top limit's infinity. And for less than 4, our bottom limit's actually negative infinity. And our top limit's 4. So we would have these two symbols be our two sets. And the intersection sign, what we would do is we would just copy paste it, where we'd just be like, okay, why don't we just move this over here and put this on the right side of the intersection sign. So whichever values satisfy both of these sets is what's the solution to the compound inequality. You can also simplify it even further if you don't want to use the intersection symbol. If you don't want to use the intersection symbol, what you can do is you can be like, what's in between, what satisfies these two sets specifically? And looking at that, it's going to be pretty easy to find the answer. It's between 3 and 4. So we can just write it like this. It's neither in 3 or neither in 4. So for and, these are the two most important and critical ways to do it. Of course, there are more complicated ways which use more advanced set theory, which is an advanced field of math. But for now, these are the only two ways that you need to know. For or, we're going to need something called the union symbol, which is actually just a regular U. And this is actually quite big. So if I rewrite it, it'll just look like this. So normally, let's say we have a different inequality. X is greater than 5 and x is less than 4 are our two things. So let's write the set. We have negative infinity to 4 on one thing, and on the other thing we have 5 to infinity. This is pretty much the only way to write it without using more advanced set theory. And this is the way to write it or inequality, like if I have x is less than 4 or x is greater than 5. And what this means is if it satisfied any one of these. So 3 would satisfy it, 6 would satisfy it, but something like 4.5 would not satisfy it because it's not less than 4 and it's not greater than 5. These are our 3 examples for today. 4, sorry. 2 of them contain and 2 of them contain or, just for a more thorough view. So if I have x plus 7 is greater than 0 and x minus 3 is less than 1, it's very simple to solve these inequalities. What we would do is we would have x is greater than negative 7 and x is less than 4. So it has to be both of these, right? So what we're going to do is we can put the intersection sign and say, or if it's greater than negative 7 to infinity. Let me rewrite that because the infinity is kind of squished in the middle of everything. So negative 7 to infinity. And our second inequality is 4 and infinity. And if we put the intersection symbol in between, it would have to satisfy in between these two. And another way to write it is negative 7 to 4 because it's in between those two things. It's not in one of them, it can't be just in one of them, it has to be in between both of them. So those two are 2 ways to write the solution for this inequality. For our second example, we're going to have another and example. 2x is less than 3 and x is greater than negative 2. This is pretty simple too, and it follows the exact same logic as the first question. We would have x is less than 3 by 2 and x is greater than negative 2, which is actually given right there. So we could do this 2 ways. Either we can do the classic intersection symbol, negative 2 to infinity, intersection negative infinity to 3 by 2. Let me rewrite that right here. If we write this again, we get negative 2 to infinity, intersection symbol, negative infinity to 3 by 2. Or we could, of course, do the negative 2 to 3 by 2 because these two, as if you can see, these satisfy both of them and no need for the intersection symbol. For our third example, it'll be the first or example. 3x minus 7 is greater than 2 or x is greater than or equal to negative 1. Sorry, not negative 1. So the first inequality is very simple. What we got to do is 3x is greater than 9, x is greater than 3, or x is less than or equal to 1. So what we have to do is we have to put the union symbol. Less than or equal to 1 would be negative infinity on the bottom and a parentheses for 1 because 1 is included in the set. that's what the main key feature here is. If you have less than or equal to, and you have to have the parentheses in order to make it correct. Union symbol, of course, because it's or, from 3 to infinity. That's our third example. That's our answer to our third example. 3x minus 7 is greater than 2 is our third example, sorry. And our fourth example is actually really easy because everything's already given for us. All we have to do is write this with the union symbol. So let's put the union symbol over here. If x is greater than 3, it must be 3 to infinity. And if x is less than 2, it should be negative infinity to 2. The easy way to do this is to see, okay, if we have x is greater than or equal to, or x is less than or equal to, or one of them, if we have x is greater than or equal to something, it'll be that value with either the bracket or parentheses, depends on which one, and infinity on the top limit, or on the right. For it's the exact opposite for less than or equal to. The bottom limit would be negative infinity, and the top limit would be our value, either with the bracket or a parenthesis. A quick way to check that a value also sets in between the and variables, because some of you might be wondering, just see something that says, okay, let's say I have a solution set 7 and 10, let's say. It's 10 is included, 7 is not. This is an and inequality. Let's say that. So let's say we have 3. It is got 3, and let's say it's 9. What we'd have to check is in between the two inequalities, represented in squiggles over here, that 9 satisfied both of these. And if it does, that's a true solution of the set, and we didn't do anything wrong. Otherwise, we would have to recheck the problem and make sure we didn't do anything wrong. For today, we're going to keep it simple, and normally in the Algebra 2 series, I'll actually be reducing the amount of practice problems because it is slightly harder, and it should also be easier not to just do it by practice, so it'll also develop just hearing naturally, and I think it'll be better overall. And also, if we have 4 practice problems, it might take too much of your time, and it might be boring for you. And I don't want it to be boring. I want it to be fun. I want to make sure that you actually learn from it. So our first practice problem is 3x minus 7 is greater than 3, and x is less than 4. Our second example is 4x plus 8 is greater than or equal to 16, or x is less than or equal to 1. Thank you so much for watching, and see you in the next one. Bye-bye.